Configuring EVPN VXLAN module. By the end, the topology used for the Ethernet VPN Virtual Extensible LAN or EVPN VXLAN example. In the example topology for this configuration section, traffic from server 1 and server 2 is tunneled across an IP fabric network. The IP fabric network consists of 5 layer 3 capable switches, which act as underlay routers. Each switch in the IP fabric is assigned a unique Private Autonomous System number, or AS number. External BGP or eBGP sessions are established between each switch device. An alternative to eBGP peering between each switch would be to configure an interior gateway protocol, or IGP, such as OSPF or ISIS, between the switch devices. This BGP peering configuration provides the connectivity of the underlay network, which provides reachability information among all underlay devices. The leaf nodes are virtual tunnel endpoint or VTEP devices, or Layer 2 gateways. The spine nodes are configured as VXLAN Layer 3 gateways. The goal is to ensure that Server 1 and Server 2 can communicate with each other. Refer to the Juniper Pathfinder web from the reference links document in the resources section of this module. To help you understand the behavior of this example, the diagram shows a logical view of the overlay network. Using the help of VXLAN and the integrated routing and bridging or IRB interfaces of the routers in AS65101 and AS65102, Server 1 and Server 2 will appear to be in the same broadcast domain. Also, the IRBs of the routers in AS65101 and AS65102 will share the same virtual gateway address and the same virtual gateway MAC address to represent a distributed gateway. If you deploy eBGP as the underlay network with family INET and eBGP as the overlay network with family EVPN, each using the same AS number, you will create 2 separate peer groups, each with a unique forwarding database. The underlay network peer with neighbor edge interfaces, while the overlay network peer with loopback addresses. You must ensure that all VTEP addresses are reachable by all the routers in the IP fabric. The best practice is to have the loopback interface used on Juniper fabric devices as the VTEP interface. Therefore, you must make sure that the loopback addresses of the routers are reachable. The loopback interface for each router in the IP fabric is configured in the 192.168.100.0/24 range. The diagram shows the tunnel overlay between the devices. These tunnels are automatically generated by the EVPN control plane. Each leaf device is a VTEP tunnel endpoint when it advertises reachability to a local EVPN VXLAN virtual network identifier, or VNI. In the diagram, you can see that leaf 2 is not a VTEP in this example. This is because there are no locally connected servers, and therefore leaf 2 does not advertise connectivity to any VNIs. However, leaf 2 will have a similar configuration to leaf 1 and leaf 3. If a server is connected to, or migrated to, an interface connected to leaf 2, the newly activated VNI will be advertised to remote BGP peers, and the VTEP tunnels will be automatically generated. The diagram shows tunnel overlays between the devices. With the spines configured with IRB interfaces, there are VXLAN tunnels between each leaf with a local VTEP interface and each spine as shown as the solid line in the example. The VXLAN tunnel between leaf and spine is used when packets require routing between VLANs, which occurs on the spine with the IRB interfaces. The packet traverses the tunnel to get to the virtual gateway address, where it is decapsulated, packaged based on the route lookup, and encapsulated with the new VNI for the destination VLAN. The packet is then processed through the tunnel to the destination leaf, which decapsulates the packet and forwards to the end server. The dashed line shows the VXLAN tunnels that are created when the IRB interfaces are on the leaf devices. With routing occurring on the leaf device, a route lookup is done before encapsulating the packet. So whether the packet is destined for an address on the same network or a different network, the VXLAN tunnels are only created between leaf nodes. Configuration parameters are common among all devices. Since the loopback addresses and directly connected networks on all devices should be advertised, a policy that matches the loopback interface and the direct protocol is configured. A common policy that enables load balancing is also created on all devices and applied to the forwarding table. Here is the example, which is a review of the fabric or underlay network configuration for a spine. Overlay network is configured as an eBGP peering group, or type external. An external peering session requires that the peers belong to different ASS. The local AS can be defined within the group or neighbor statements, or the AS number defined under Edit Routing Options Autonomous System can be used. If the local AS parameter is not defined in the peering group, the global AS number is inherited by the BGP protocol. The loopback interface is not directly connected between fabric devices, so the multi-hop parameter is required. Also, you want the leaf loopback address to appear as the next hop in the overlay path. To achieve this, you include the No Next Hop Change option to the multi-hop parameter to prevent the spines from injecting their address into the path. The local address option identifies the loopback address as the source for the BGP overlay. Because all eBGP peers belong to different autonomous systems, the multipath statement enables equal cost multipath or ECMP among the eBGP peers with the additional multiple AS parameter. The family EVPN signaling is configured on the overlay. This limits the BGP session to only advertise EVPN type routes. IP routes are not advertised between overlay peers. Make sure all VRF policies and BGP policies are processed before advertisements are sent by including the VPN apply export parameter. Here's the example, which is a review of the fabric or underlay network for a leaf node. It shows an eBGP overlay configuration. The leaf devices only peer with spine devices. Peering with loopback interfaces requires the multi-hop parameter, and to limit the scope of travel, set the time to live or to 1, which will enable an advertisement beyond the device edge interface. Once again, the overlay is only going to advertise and receive EVPN routes, so the family EVPN signaling is configured for the overlay peers. You want to make sure you enable ECMP by including the multipath multiple AS option, as well as normal BGP protection schemes such as BFD. Make sure the VPN policies and BGP policies are processed before advertising by including VPN apply export in the overlay configuration. This is on each fabric device. Issue the show route command. The example shows the command to verify routes to the loopback addresses in the 192.168.100.0/24 range on leaf 1. Show BGP summary command displays the BGP neighbor status for the underlay and overlay BGP peering sessions. A key difference between the two types of sessions is the routes that are advertised between peers. The fabric peering sessions are exchanging IPv4 or family INET routes. The overlay peering sessions are only exchanging EVPN type routes, as indicated by the BGP.EVPN.0 routing table information